This is the guts of a Ryobi P110 1+ tool system nickel-cadmium battery charger. Just got one of these, 2 NiCd batteries, 2 P700 flashlights, and a drill, the part number of which I do not recall, for a very good price today. Well, technically yesterday. And so, naturally, having one of these, see what's inside it. Looks to be fairly simple. No ICs or anything in the charge control circuitry. It looks to be just a whole bunch of things like just resistors, capacitors, and transistors. Although some of them might be TO92 package LM431s or some kind of potential reference to that in there, or probably Zehners, because there's also some diodes in there. So again, fairly simple charge control circuitry as you need with nickel-cadmium batteries, because it's a fairly forgiving cell chemistry. So it's just a Gray's bridge module there, a unmarked. Well, it is marked, but it's marked X0405. Some TO18. No, it's a TO218 package, which is somewhat unusual nowadays. Power device. That's obviously just the main pass transistor for the battery charge current. A couple, well, at least one Recon branded. Can't see what the mark on that is, so obviously no name Chinese caps. 3 idiot lights for just the various states of charge. And linear power supply. Just a transformer and fuse on a PCB. Interesting to see they did that instead of using an inline fuse holder or anything. But it means the fuse is replaceable. One interesting thing, though, is that the date code on the bottom of the charger is week 37 of 2006. The date code on that transistor is 639, which is usually, in this case, week 39 of 2006, so I don't know if that might be some kind of internal factory code or something, but then again, considering that the batteries, well, they're made in 2006, so they're very close to the end of their service lives, but they seem to charge better on one of my IntelliChargers that I have, so this is largely just going to be an emergency backup kind of thing. And then there's just these contacts which go into this recess in the case, and that's pretty much it. There isn't a whole lot else in this thing. And of course, pure through-hole load, given the age of this. Although, granted, that makes these things like this much easier to repair. Really, surface mounting stuff is really only flux gun. Yeah, looks like flux gunge in those 3 joints where we worked at some point. Actually, yeah, that's probably because... Actually, no, that's probably because the proper way of mounting a transistor like this is that you mount it to the heatsink, then you put the heatsink on the board, and then you solder it. That explains the presence of the flux gunge in that case. So they didn't do that with the... Obviously, this board was probably wave soldered first. And it's also the flux gunge around the LEDs. The LEDs were probably, the LEDs in that transistor were probably added at a later date, but it's interesting that you don't see that around the rectifier. But anyways, really things like surface mounts only good if you're having everything be purely machine-made, or as much automation of your assembly as is possible, and it's stuff that mortals are never going to have to fix, because some packages aren't too bad to deal with. Things like small outline, 50mm pin pitch ain't that bad. The main problem is that there's nothing mechanically holding the device to the board. You need to worry about the sliding around and soldering. And things like PLCCs, which of course have through-hole sockets available for them, which is actually why the industry is trying to move away from those. That's why it'd be really advantageous if they made a suitable micro in that package for my maximum power charge controller project. But yeah, things like BGAs, LGAs, QFNs, and these umpteen hair width between pin TSSOPs and all that other horrible stuff. They're homo beta for anything that mortals have to worry about.